Hello everyone. Today we're going to be looking at an old matric paper. We're focusing on databases at the moment, and back at around 2010, 2011, the matric papers included a SQL component where you had to add SQL code into Delphi. All that was examined was the SQL, so that makes it a very good candidate for what we're trying to discuss at the moment. We'll be looking at the 2010 March paper. Open the project file, that's question 1p over here. That will open this little file. You'll notice we are going to be using question 1u, which contains the unit that you're going to be programming in, and also a data module, in this case question 1dm. Let's open question 1du and question 1dm. Question 1dm just contains an ADO connection, query fat fighters, and the data source fat fighters, which we're going to be using in our unit. Inside the unit, we have at the moment no code, apart from that needed to establish the connection. You're not going to change that at all, so let's have a look at the form. The form gives us several buttons, all members, weight differences, overdue accounts, lowest weight, weigh-in history, and adjust weights. We'll be adding code for each of these as we go through the questions. And this is our task. Fat Fighters is an organization which tries to help people live healthy lifestyles. We're not too concerned with that. What we are concerned with is what we have to do. So, Fat Fighters want to see a list with all the information on all their members. Complete the code for the All Members button. This is going to be a basic SQL select statement. It's a statement to display all the details of each member stored in the table people table. Order the results by expiry date in descending order. Remember, a select statement is going to look something like this. Let's go to All Members. Just starting with the basic select statement. One doesn't have to use all capital letters. I'm doing that in this particular case to try and keep it visually distinct what is SQL and what is going to be Delphi. So the SQL statements will be typed all in capitals. So select everything from table people, and then they said we want to order it by entry date in descending order. So order by entry date, and to order these things in descending order we add the keyword desk. Right, this is the SQL that we're going to be using in it. What we need to do now is add this SQL into a Delphi statement which will send this through to our Access database. There are a few steps we have to go through, starting with referencing the data module. Remember, that data module is called DM. If you look over here, question 1, DM, this entire form is the data module and its name is DM. Right. So we're going to be referring to controls that are on part of that data module, specifically the ADO query. And the ADO query's name is this one, query fat fighters. So, query fat fighters dot active is false. Always start by setting that query to false. We're going to be making changes and we cannot do this on live data. Setting that to false basically deactivates the control. We can now make any changes we want, and when we make this active again, those changes will then be sent across to the Access database and made active. At this point, we don't know whether there's a pre-existing SQL statement or not. So let's clear that field, make sure there's nothing there. We're starting with a nice blank slate. The SQL property of the ADO query is also a t-string list, just like you'd find in a t-memo or t-rich edit or t-list box. So it has the same properties and the same methods. It also means I could have typed sql.text here instead, sql.text, and typed my whole SQL statement after this. But to make it clear that the SQL I'm typing is this same SQL, and to make it a little bit more readable, I'm going to be typing it in individual lines. So I will be using the add method from a t-string list instead. We're going to add, starting with exactly this line. Select asterisk. Remember, the asterisk is a wildcard character. A wildcard character means that will match any column in this context. This is going to show all columns. Right, let's add the next one. This will come from table people. And we're going to order it by expiry date or entry date in descending order. And there it is. We have the SQL statement, exactly the same statement that I wrote just a moment ago. Select all the columns from table people, order by entry date in descending order. All that remains is we must now make this active. If we execute this code, I should end up with all the members. All right, let's have a look at the second question. They want to know how much weight their members want to lose. This is calculated by subtracting their goal weight, G weight, from their initial weight, S weight. So we're going to be using a calculated field to hold this thing. You're going to have to display person ID, name, S weight, G weight, and the difference between the two weights in a field called kilograms to lose. And this is for all members. So we're not going to be filtering this in any way. That means no where clause. Note here, kilograms to lose must be rounded to 1 decimal place. So we're also going to have to use the round function. This is the round SQL function, not the round Delphi function. This happens when the procedure has, in this particular case, it happens when I've typed something that I shouldn't have. Oopsie. Okay. Right, we're here. Drag and drop can be a pain sometimes. All right, we're going to be doing exactly the same thing. And as such, no reason why we can't take a small shortcut. They said we are going to sew these particular columns. We want person ID, name, S weight, and G weight. So those are the columns we're going to add. No asterisks this time. person ID, name, G weight, S weight, and now we're going to add our calculated field. The difference between the two weights in a field called kilograms to lose. The formula we're going to have to use is S weight minus G weight. They want this rounded to 1 decimal point. So we're going to have to use the round function. And now we have to name the column. We use the as SQL statement to do that. Naming this column as kgs to lose. We're not ordering it, so we don't need that, but it's still from table people, and we make it active. Spelling is always important. And there we are. All right, let's have a look at question number 3. Question number 3, we want to look at non-payment of members. Fat fighters want to delete all members who have an outstanding balance greater than 400 Rand, except for Uriel Knight, who has made special arrangements in terms of her account. So we're going to be using an SQL delete statement. The statement is going to look a little bit like this. We're going to delete from table people all right, let's have a look at our data again. This is our database. And in table people, we're going to be looking at the balance field. This means our where clause, where balance is bigger than 400. Notice I just say greater than. So people who are just on 400, they're still safe. Only people who are bigger than 400. And name is different to, we have to make sure we spell this girl correct, Uriel Knight. Obviously, you'll have to type this in your exam papers. Uriel Knight. Right, that's the basic idea. This is the SQL statement we're going to need. The process we're going to follow is basically the same as we've used before. I'm to start with deactivating the ADO component. So active is false, and we clear the SQL. There's going to be a small difference when we execute this. I'll come to that. All right, deleting from that table. Where balance is bigger than 400 and name is different to Uriel Knight. Remember, an SQL statement also ends with a semicolon. Don't let the fact that Delphi ends a statement with a semicolon make this complicated. The portion inside those inverted commas, that's the SQL. Now we need to execute this SQL. Because this does not update any display components, I cannot just make this active. I'm going to have to use exec SQL to tell Access, execute this SQL. If I were to try and make this active, I would not have a set of return data to display in the DB grid on the form, which would cause an error. So this is where this one will have to stop. Overdue accounts. Now, I wonder if that worked. Let's have a look in the actual database itself. And all of a sudden, there is one left, which wasn't supposed to be, but that is Uriel Knight. There we are. And the other 400s are all gone. Let's have a look at question 4. Members want to know what their lowest weight was so far. So we're going to be trying to find the lowest weight. So we're going to be using the min function. Remember, min is an aggregate function. Aggregate functions need to be used with grouping. We'll be using the group by statement to group fields together to then determine the minimum weight. Our SQL is going to be looking something like this. We want to select person ID. We also want to select the minimum of weight. We're going to be taking this from table weigh-in over here. Let's have a look quickly at table weigh-in. We've got the field weight, person ID, and a weigh date. In most of your exam papers, you'll be given the table structure. I don't have it handy, so I'm referring to the actual database. So, min weight as, and the question asks us to call this min weight. Min weight from table weigh in. We're taking it from this table weigh in as specified. And now we want to tell it how we need to group the information. So it'll be group by person ID. There's our SQL. Same procedure. We start off by deactivating the SQL query. Remember, there's no guarantee that the last action was that delete function, which left this in a deactivated state. So we have to make sure that we deactivate it anyway. We're still going to have to clear the SQL, and then we're going to start typing our new SQL statement. select as min weight from table weigh in, group by person ID. This is a select statement, so it will provide something that will update in the DB grid, affects display. So we're going to make this active like that. And there we are, the lowest weight for each particular person. In question 5, we're asked to complete the code for the weigh-in history button. Weigh-in history button needs to provide the ID, name, goal weight, weight, and weigh date. And you'll notice that we're taken from the table weigh-in and from table people, which means we're going to be using an SQL join statement. We need the intersection of these two tables. So our SQL will look a little like this. We're going to select people ID and name and goal weight, and weight, and weigh date. In this particular instance, the names of the columns in the two different tables are very distinct. If they were not distinct, I would have to preface each of these columns with the name of the table that they came from, as in table people.name. All right, from, now we have to specify the two tables, table people, and I'm going to create that join. SQL defaults to an inner join if you don't specify which join, but I prefer to be precise about this, so I will be specifying inner join table weigh in. All right, I've said we have to join these tables, but I haven't yet said how we have to join these tables. We're going to do that by joining them on table people dot people ID is equal to table weigh in dot people ID. Okay, this also says that we're going to specify which person we're looking at. This mustn't just list everyone. That means we need a where clause. Where person ID equals whatever it is that we're going to type in. I'm just going to leave that like that for now. But we are going to actually have to put a value in there. That value will come from an edit box or an input box, which we're going to have to create in a moment. So we need an input. We'll use an input box for this, which means we need some place to store that value. You can use any caption you like, and any message. We have no default value. That will give us the ID that we're going to be using in the code. So over here, I will be entering the value that I created. But remember, this value is going to come from Delphi. Everything else is SQL. We're going to have to combine these two. Same procedure. First, deactivate the SQL query. Clear everything from that query. And now we're going to add our first line, our select statement. Make sure you end your strings properly. Right. Over here, up till there, is SQL. This value is going to come from Delphi, which means I need to add that string in there. Someone typed this in as a string in that input box. If it was typed in as, if it was a value stored as a number, I would have to convert that to a string. But remember, it is a string that is being sent to Microsoft Access. And that will then interpret it and interpret the numbers appropriately. This is why we have to use inverted commas when we are sending strings. It's to tell Microsoft Access in this instance that we're working with a string. That's what happened here with Uriel Knight. We're sending this entire thing as a string. Access will then see these inverted commas and say, ah, the bit inside there is also a string. The problem when you have one program communicating with another program. So we've sent our, we've sent our number. We still have to complete the SQL statement. And there we are. Last step, always, this is a select statement. Let me just get rid of these two things. This is a select statement. So we finish by making it active. At this point, person ID could refer to either of the tables. We need to make that clear. Otherwise, this where clause may give us some problems. So, table people dot person ID, and let's see what happens. Select one. Person ID over here can also refer to more than one person. It doesn't actually matter much which table we use because it refers to the same value. But that should work there. Let's just see. And this is my spelling mistake somewhere. Over here, please note, spelling is always very important. Person ID. And there we are. Tegan Gentry, and a little bit later on, various weights. All right. Last question, question number 6. Fat fighters have realized that the scale they used to weigh their members gave incorrect readings during the month of May. All readings for May should be 10% higher than recorded. That's going to lead to a lot of disappointed people. Complete the code to adjust the weights by increasing all readings that were done in May by 10%. The done in May portion means we're going to have a where clause. In any case, for any update, you want to have a where clause to avoid updating all the records. That can also mess up your data, much like not having a where clause in a delete statement. So, last one, adjust weights. Right. Same procedure. We're going to mock up the data. This is going to be an update. So we're going to update and we're going to be updating table weigh-ins. Yeah, we're going to be updating table weigh-in. And we're going to be setting a particular column. We're going to be setting the weight column to a small calculation based on the weight column. So weight times, you can do this in various parts. Weight plus weight times 10%, or as I'm going to do it, increase by 1.1. And now the where clause, leave this out and it will update all the values. We only want those for the month of May. Where, and in Microsoft Access you have the month function. Month of weight date equals, and May is number 5. That should do our job. So we're now going to do the same thing here. We're going to set active as false, clear the SQL, same procedure as always. Then add these lines. Last line, remember, this one also does not affect the DB grid. We're not looking at something which is going to be displaying data. This means we're going to have to use exec SQL and the DB grid will be left blank. Nothing visual, but hopefully if I go into that database, I will see that everyone has increased. Seeing as I didn't show the values just before the increase, you'll have to assume that they went up. Anyway, that's it. The end of this particular little paper. I hope that's been of some use to you. Bye.